These are the Alice notes for Section 6. Section 6, the quotient of powers property. When dividing two terms with the same base, the shortcut is to keep the base the same and subtract the exponents. Keep your power positive by looking whether it belongs in the numerator or the denominator of the fraction. For example, if Alice eats 3 ounces of base 2 cake and drinks 7 ounces of base 2 beverage at the same meal, Alice has more to drink, so she is going to shrink. Let's look at that as an exponent expression. So Alice having 3 ounces of base 2 cake, so that is 2 to the 3rd power. And then Alice had 7 ounces of base 2 beverage. We know that the cake belongs in the numerator and the beverage is in the denominator, so let's write this as one expression, 2 to the 3rd over 2 to the 7th. So we're going to look and see that we have the same base, and so we're going to subtract the exponents. And so 7 minus 3 is 4. She had more to drink. The 7 is larger than 3, so the answer of 2 to the 4th is going to be in the denominator, which shows that Alice would shrink. Next example, Alice ate 9 ounces of base 2 cake and had 2 ounces of base 2 beverage. So 9 ounces of base 2 cake is 2 to the 9th power, and 2 ounces of base 2 beverage is 1/2 to the 2nd power. If we write that as one exponential expression, we would have 2 to the 9th over 2 to the 2nd. And again, we're going to subtract our exponents. 9 minus 2 is 7. 9 is the larger, and so 2 to the 7th goes in the numerator. Again, Alice had more to drink, so Alice had more cake than drink, so she's going to grow. So, for the rest of our examples, let's take a look here. So, just in our same format that we've had here, a to the m over a to the n. A's are the same base, so that we know we can subtract our exponents. Let's say that m is bigger than n. Then our answer is going to be a to the m minus n. But if n is bigger, your answer would go in the denominator, so it would be a to the n minus m. We are going to avoid negative exponents, and so you would always take the larger number minus the smaller and put the answer where the bigger exponent was. So on this next example, 2 to the 7th over 2 to the 4th, 7 minus 4 is 3, so our answer is 2 to the 3rd. It's going to be in the numerator because 7 is larger. Whereas on this third example here, on the top line, 3 to the 5th over 3 to the 9th, same basis of 3, we know that we can take 3 minus 5, 9 minus 5, and your answer is 4. But we need Alice to shrink, right? She had more drink than cake, so it would be 1 over 3 to the 4th. On these answers here, feel free to look at your pink sheet and say that your final answer would be 8, 2 to the 3rd is 8, or 1 over 3 to the 4th is 1 over 81. All right, next examples here. 8x to the 10th over 2x to the 4th. So 8 and 2, they are coefficients. They are not exponents, so we're not going to subtract them. We are going to reduce them like a fraction or divide. So you can ask yourself, how many times does 2 go into 8? And it goes, so 8 over 2 would reduce to 4. So in our numerator, we're going to have 4. And then we have the same bases of x to consider. 10 minus 4 is 6. So our final answer is going to be 4x to the 6th. You can put that over 1, but you do not have to. 4x to the 6th without the fraction bar is the simplest form. Okay? So I'd like you to go ahead and pause this video, try the next 2 examples on this row, use the same strategy that we did here. When you're done, hit play. Okay, let's see how you did. So 8 over 2, again, is going to reduce to 4. However, this time, we have a higher exponent in the denominator than the numerator. So this time, 10 minus 4 is 6. It's going to be in the denominator. And on the third one here, the 2 over 8, it would reduce to 1/4. And the exponent of 10 is greater than 4, so our answer would be in the numerator. And 1x to the 6th is just the same as writing x to the 6th over 4. If the exponents would have, well, I guess that's the next example. Let's go ahead and look at it. So on this next example here, we have 2 over 8. And this is what I was just getting ready to explain. So the 2 and 8 again, that reduces to 1/4. And the 4 this time is in the numerator smaller than the 10. And so 10 minus 4 leaves us with 6 of those x's left in the denominator. So that 1 is necessary on this example, but the previous one where we had something else in the numerator, you don't have to have the 1 here. So again, take a look at this example where the 1 isn't needed, but on this example it is needed because there's nothing left in the numerator. Okay, so we're going to go ahead and do this example together, and then you'll try this one on your own. So we have 15x to the 3rd, y to the 7th, over 5x to the 10th, y to the 11th. So it's really important that you realize that the 15 and 5, you're going to reduce them like a fraction. So you ask yourself, how many times does 5 go into 15? And that is 3. And I'm going to put that in the numerator and you can say that 15 is bigger than 5, so it would belong up there as well. I have 3 x's in the numerator, 10 in the denominator, so I'm going to have 7 left in the denominator. I have 11 y's in the denominator and 7 in the numerator, so I will have 4 left in the denominator. So 3 over x to the 7th, y to the 4th. So again, go ahead and hit pause. Try this last example. When you are done, hit play. All right, so our last example here, we have similar exponents here, but our answer is going to be different. This time the 5 is going to divide into the 15. It needs to go in the denominator because that would reduce to like 1/3. We have 10 x's in the numerator, 3 in the denominator, so we're going to have 7 in the numerator. And we have 7 y's in the numerator, 11 in the denominator, so again that y to the 4th belongs in the denominator. And so because we have x's up here, this 1 is not needed, so I'm going to rewrite this in simplest form. So it would be x to the 7th over 3y to the 4th. That concludes our notes for section 6.